Git implements a very fine-grained file lifecycle. Some see that as overly complex compared to more basic tools such as Subversion. They feel that this requires too many steps or commands to achieve common tasks, but this is an incorrect perspective. The purpose of Git is to give us a lot more freedom and possibilities than legacy tools, by letting us be as surgical or wholesale as we want, but always fast. In order to work smartly with Git, there's no way around it. We need to learn it. And the best way to go about it is by looking at the concepts that underpin it, starting with the zones Git uses to craft commits and turn them into a history. Depending on what zones a file is in, it will transition from one state to another, starting as untracked all the way to committed in Git. There are 5 zones in total. They are often categorized by how frequently you use them. This also makes them easier to explain. We start with 3 main zones: the working directory, sometimes called the working copy; the index, whose name varied over time but is often referred to as stage, staging area, or in legacy docs as cache; and finally the local repo. In version control we often say repo instead of the full word repository. And the working directory is our current project tree on disk, where we actually do the work. The index is sort of a buffer zone where we craft and fine-tune our upcoming commit until we store it in the repo. It is super useful as it lets us refine over time what files and even file parts we want to put in the next commit, which isn't necessarily all of our ongoing work. The local repo is basically a database that stores commits and other version management data. These 3 main zones are what we all use all the time when building a commit history. We use a bit less the 2 remaining zones. These are the stash, that lets us set aside some ongoing work in order to address an emergency by starting from the relevant clean slate, and the remote repo that we use to share our commit histories and synchronize with other team members. Synchronization happens between our local repo and any number of remote repos, often just one. In Git parlance, remote repos are often referred to as just remotes. So let's look at how the 3 main zones are used when creating commits. A commit stores information about files that were created, updated, or removed. To prep a commit, we thus start in our working directory. For instance, here we create and update files A, B, and C. We originally intend to use all these in our commits, so we add them to the index, which prepares snapshots of them. We then realize that files B and C are about a different topic than A, and as we want to play nice and craft single topic commits, we decide to take them off the index. We then edit C again, that becomes C prime on the diagram here, and because it now contributes to the topic for the upcoming commit, we add it to the index. And this now looks good to us, so we validate that by creating the commit. Should the commit require extra updates, we'll have to undo it whilst retaining the work it contained, either by rolling it back to indexed files or by backpedaling all the way to the working directory. And in both cases, we forget, so to speak, the commit itself, but not the work that went into it. We're just going to craft another commit with it instead. Finally, we may want to just scratch that commit's work entirely, erasing it from all 3 zones. You noticed? I said we forget the commits. I'm emphasizing it because Git won't immediately remove the relevant objects from its database. It only stops referencing them, as we'll discuss later. Chaining commits on top of each other builds up what we call the version history. If we repeat the transitions we saw through all 3 main zones, we get a first commit, and then a second, and a third. Notice how in the local repo we use arrows here between commits. They link commits together from child to parents, describing a temporal sequence. By the way, a commit can have multiple parents, as merge commits do. You can even get more than 2 in what is called an octopus. At the end of the day, you get a tree of commits that are all the successive steps of work that made up the project's current state. And so far, our tree is really just a single linear trunk, but when we talk about branches, it'll get richer than that. In addition to zones, it is important to understand the states through which our files go, and how to navigate these states. They're tightly related to the zones our files are in, but Git will only display relevant states at any time, so states for anything not known to the current base commit. In short, anything of note in a working directory or index. Let us look at a common lifecycle for a file. So the file is created. From then on, it is deemed untracked because Git doesn't know about it, neither in the local repo nor in the index. When we go ahead and add it to the index in anticipation of the next commit, it becomes indexed, more widely known as staged. We then greenlight the index and create the commit, which makes the file appear unchanged because its snapshot in the new base commit matches that in the index and the version in our working directory. If we now modify the file, it will be, guess what, modified, as Git sees it's different from the snapshot in the index. Then if we stage and commit these changes, we're going through the usual staged and unchanged states again. How would it go if we removed the file? Well, it's pretty much the same thing as an addition or update. Git sees the removal from the working directory as a modification that can be staged, then committed. Doing that will create a new base commit in the local repo that doesn't reference that file anymore.